Oh, one more thing, I forgot to turn on the recording. In future, if you see I haven't turned on recording, please let me know, because otherwise you won't be having the recording, right? So now I have turned on. So let me share the screen. Okay, you can see this, right?
Yes.
Okay. This, okay. So with REPL, basically you can create account using, I think you can create using your Google account, or GitHub, or I think there are a couple of options where you can create account in REPL. Now, once you do that, you can log in, and what you will see is you will see something like this with a hello world. So how do you run this? Is you just can press this one, this run button, and it will compile the code and run it. Right, it will do both, like compile and run. Now there are other ways you can compile and run this. So it's how you can do is ncpp. So this is how you compile it using the GCC, and once you do that, then how you run is /main. So that you can run it. So, and running it using this button is always easy. So so I'm just telling you the other options. Now now let's do it. Let's just delete this and example of pointers, right? Okay. Let's just declare a variable as I've done in the slide. So here what we have done is we have declared a variable a, and we have assigned the value 5 to it, right? And how you print is, you can do it with me if you have access to Visual Studio or even REPL. You can do it with me, or if not, you can just observe, and both are fine. So how do you print is, so please bear with me. I'm just starting with the very basics, because I'm not sure how the students can be of different levels, right? So there could be students who are going to major in electrical and power engineering that may not have the same expertise as of students of software engineering discipline. So I'm going to start with the most basics. So what we have done here is we have created a variable a of type integer, and we have assigned the value 5 to it. And with this, what we have done is we have printed. So to print, you can use cout. Now, if you don't have this using namespace std line over here, you'll have to type like this. So you have to call std, and inside std you have to access cout. Right? So instead of that, you just switch to the namespace std, and then you can just print it using cout. Okay, so you can see the value is 5. So this is a very basic example. Now let's see what's the size of this a. Now how many bytes are allocated to this a variable in the memory. So a, there's a command called size of, right? Oh, so again, as I mentioned, for integer type variables in the memory, there's 4 bytes have been allocated, right? Now let's declare a variable, a pointer type variable, and let's just point it to the address of A. So what we have done here in the line 11, what we have done is we have declared a pointer type variable, and we have directed it or assigned the address of A to this pointer P, right? That's what we have done. So you can do it with me if you have access to Visual Studio or REPL even, right? So I'll give you maybe a couple of minutes for you to open Visual Studio and REPL so that you can do it with me. Okay, I'll give you 2 minutes. Just open Visual Studio if you have, and if you don't have, just you go to the browser. REPL, right? Yeah. So the link to how the URL is REPL. Yeah, repl.it. So this is the URL. You can just go to the site. So since I have already logged in, I can see my codes here. So if not, since if you are logging for the first time, you can just create, press plus here, and then search for a template. We are going to use C++. So just select C++ from here. Select C++, and then you can create a REPL. Just if you click this, you will go to over here, right? I'm not going to do that because I already have created one. So let me know if you have any question. I'll give you 1 more minute to open it. I believe you have already opened REPL or Visual Studio. So let's continue. So again, what we have done here is we have created a pointer type variable P and assigned the address of A, which is this one, to P, right? So let's just first print what A is. Let's see what is there in the memory location of P. Let's just run it. No, over here. See, this is what is inside P, right? Let me. Okay. So over here, so see, so this is what is inside the P. That so basically this is the address of A. So in memory, now if you see, let's say this is your memory. Now in the memory, A is there somewhere, and the address of A is this one. So this is the address, right? And now pointer P is also there somewhere in the memory, in the same memory, right? So what it has is this address. So starting with OX, right? This is the address. So the cell that belongs to P has this address, and this address is actually over here, right? And inside A, the value is 5, right? Is something like that. So basically, there are 2 memory cells. In one, variable A is there. The other one, the variable P is there, which is a pointer type variable. So inside P, the address of A is there. Right? Inside P, the P cell, the address of A is there. So are you clear on that? Any questions? Any questions? No? Okay. So hope it is clear to you. Okay. So let's go on. Okay. Now we have printed the value of P. Should we do next? Let's see what's the value with address P. Can somebody answer what should be the value? What should be what should print here? 3645 Kumar Singh. What should be printed? If you run this, what should be the output of this line?
5.
Okay, let's run and see. Yeah. So yeah. So as I mentioned, so what's happening here is, so the memory, there's a variable A, integer type variable, and also there's a variable P. Now the variable P is a pointer type variable, and he is pointing to the address of A. Now, if you want to access the value of A, what we can do is we can go through the address, and if you type star P, that means what we are doing is we are basically addressing the memory cell with the address P, right? So and then we will be printing the value. So that's what we are doing, right? I hope it's clear. Now let's do one more thing. Let's change this the value. Just change the value where this address P is. So basically the A, right? So what we are doing here is basically changing A. This is similar to A equals 6. It's exactly same as that. And then let's just run and see what's the value. Oh, let's just run type A. Right. See, so we have changed the value of A by going through the address, right? Is that clear? Clear, right? Okay. So that's the fundamental thing about pointers. So it basically goes with the address. If it is clear, so let's just go into the next thing. Okay. So we were here. Okay, now let's go into specific data structures. So we have learned about the variable declarations and pointers, and now terms of data structures, there are a couple of data structures, and we can basically divide them into physical and logical. The difference between physical and logical is, so with physical, there will be actually in the memory, these variables are there. For example, if I put it in a different way, I put it in a different way. Now let's say array. Let's take array, for example. So in these physical data structures in the memory, so these are there, right? Now these are there as it is. Now going to logical data structures, in logical data structures, what we are doing is, what we are dealing with is some implemented or conceptualized data structures that are created using these two physical data structures. For example, stack is a stack can be created using arrays, but the difference in stack is data we put in will go to the last element. It will be put at the last location, and if we read it from a stack, what we are going to get is the last element. So it's like last in first out, or something like that. Now queue, whereas Q is just like in a normal queue where you see in the gas polymer, thread decay, and so we are seeing queues, right? So just like that, you will be entering into the queue at the last position, and you will be going out from the first position, right? So you'll have to wait all the way until you go into the shed petrol gas right? So these are like data structures that has very timely value, right? So the difference is, as you can see, the difference is these are logicalized, like conceptualized data structures, whereas these are the fundamental data structures. These are the ones that they are in the memory, right? Whereas these logical ones are created using these physical data structures, right? Okay, so that's the difference. So we're going to start with array. Array is like the most fundamental data structure that you can see. Give me a second. Sorry for the disturbance. HOD called. So, okay, so we were discussing array, right? So array is like the most fundamental data structure that you can find. And in the memory, how it is, so in the memory, as you can see over here, so you can see over here, right? So in the memory, the array is a consecutive so it's a linear data structure which can store fixed size collection of element of the same type in a consecutive memory location. So the most important part is this. Take note of this consecutive. So you see the variables are there in the memory consecutively, right? And also the linear part is also important. Now, okay, so it's a consecutive thing. Like for example, now if we create let's say we create an array with int x5, let's say we create an array like this. So what happens here is in the memory there will be 5 consecutive integer cells, 1 2 3 4 5, and this is x, right? So in the memory it will create so each cell would be, because this is integer type, each cell will be 4 bytes. Okay, so about 20 bytes will be created in the memory consecutively, right? And how do you access each element is using index. Now as you see here, so we start with index 0, not 1. We start with 0. So if you want to access, let's say, the third element here, so we're going to have to access it using x2. Because we start with 0 index, it's 0 index, it goes with 0 twice. So the third element would be 2, right? So if you want to read the value in this cell, you're going to have to access it using x2, right? So we will be declaring or creating arrays using. There are a couple of ways you can create arrays, but this is one of the fundamental ways is like this. And if you want to access, you'll have to access to index. Okay. So now in this example, if we access A2, see this is A2, and it will return the value of 1. Clear? Okay. Okay. So with that being said, now the advantages of arrays is the main advantage is it has we can access element directly. Don't have to go through one by one to access a certain memory element. Now, if you want, let's say we want to access this one. Let's say we want to access this one, we can just directly access it using, sorry, this is A, right? A3. We don't have to go one by one like this. We don't have to go one by one. We can just directly access it. So that's the main advantage of array. If we know the address, we can directly access it. So it's very fast. But the counter, no, the main disadvantage or the con is the size is fixed. Now, if you want to, now when you declare, now in this example, we have declared array of, now this is of size 6, right? This is of size 6. Now, so that size is fixed. Now, if you want to have a array of 8, you will have to redeclare it, or you will have to copy this A array into another array and create the array of size 8, right? So that's the main disadvantage. And apart from that, inserting elements and deleting element is not as efficient as some of the other data structures. For example, now what the meaning of that is, let's say you want to insert the element at this point. Let's say you have to insert 10 at 4th position. Let's say at 4th position you want to insert 10. You might think you just need to, what you need to do is A4 equal 10, right? You might think that's what we need to do, but it's not the case. When we insert 10, now if we do it like this, it will replace the current 3, right? Currently at 4th element, then we have the value 3. Now if you do it like this, it will be replacing 3. What we need to do is we need to add 10 at this position in between 1 and 3. So in order to do that, we'll have to shift. So let me show another color. We'll have to shift all these. Sorry, we'll have to shift all these into right hand side. So it's a very time consuming task. And similarly, deletion is also same. Now say we want to delete this number 2. We can of course delete this, and the time consuming part is we'll have to shift all these over to this side. So it's a time consuming task. So the insertion and deletion is not as efficient as some of the other data structures. So more about arrays, and maybe I'll explain these through examples. Let's just go into REPL, or you can go into Visual Studio. I'll be doing this example, so it will be more efficient, right? Rather than just commenting over here, it will be more efficient. Maybe I'll quickly go through because you need the notes, right? At the end, when you're gonna study, you're gonna need these notes. So I'll quickly explain what happens here. So this here, what we have done is we have we have created the array of size 5. We have created an array, my handwriting of size 5, but the important thing here is we haven't initialized this. You will see when we go to the examples, when we print this, what will happen. Let's see what's going to happen. The important thing to take note is this is not initialized, not initialized. Okay, not initialized. Now, how compared to that, what happens here is we are creating array of 5. At the same time, we have initialized this to certain values, right? This is an initialized array. Here we have created an array of size 5, but by using this, actually we have initialized that to 0. Now when we do this, what happens is it will create an array of size 5 with zeros. All the elements will be zeros, right? Okay. Here we have created an array of size 5, but only the first two elements, 2 and 4, are assigned or have been assigned values. All others will be 0. So here we have, so no, see that here there is no value, right? So what we have done here is we have created the array exactly like this. The array only consists of 3 elements, that is, and the values are 2, 5, 9. Okay. And the last one is we have created the array, but no memory is allocated for this kind of arrays. The memory you won't see that nothing is allocated. Okay. Okay, so let's go into a practical example. I'll do this with REPL, and okay, I'm gonna delete this. Okay, let's just do this with REPL, and then after that, let's go into Visual Studio. Now, if you have Visual Studio, you can do it directly over there. For the students who don't have access to Visual Studio, I'm gonna do it with REPL. Okay. Up to this point, do you have any questions? Any questions? Or if you can't no, directly tell me, you can just type it in the chat even. I'll really appreciate if you have any comments, because this is the way even we learn, right? I'm not expert to learn teaching, right? So as I mentioned, I was a student like you a couple of years back. I may have some expertise in this domain or research wise, but I do not have much expertise teaching wise. You know? So I really appreciate if you can give me your comments. If you don't, if I'm speaking too fast, if my pronunciation is not clear, if I'm too slow, so just, and if the voice is not clear, just tell me. You can just type it in the chat as well. Okay. So okay, let's go to a practical example. Okay, let's create an array of size 5, and initialize it to, let's say, 1, 2, 3, 4, 5. And how do we print this? Uh, can you maybe type in the chat if you don't have access to Visual Studio, because doing this with Visual Studio would be much more efficient, because it has this debugger option, so that I can teach you debugging, how to do debugging as well. So if you don't have access to, maybe not at this moment, but going further, if you don't have access to Visual Studio, can you tell me maybe in the chat? Can you hear me? Can you hear me? Is that the mic? Yes. Okay. Okay, just drop me a message in the chat if you don't have access to Visual Studio. Okay. Meanwhile, give me a second to plug in the charger. Okay, I didn't receive any comments, so I assume that you all have access to Visual Studio. So let's just switch to Visual Studio because it will be more efficient if we do it in Visual Studio. So, okay, let's switch to. Okay, so this is basically Visual Studio, right? So let me teach you how to create a new project. So just go to new project. That select console lab, this one with C++. Select this one and press next, and just give some name. EE33022022, right? Okay, I'm going to create this one. Okay, so yeah, we will end up here. So this is your main file. So let's do some coding with this. Okay. So let's create an array of, let's say, size 5. You can do it with me if you have access to Visual Studio. It's better if you can do it with me so that now these type of modules or courses, I mean software courses, is always about doing, rather than memorizing. Memorizing won't get you far ahead. Like, of course, you may be able to pass the module. I have some friends who have passed some software modules in my time by memorizing everything. So is not, I'm not going to say that it's not possible. I have friends who have they don't have much expertise or knowledge in software engineering. So some of the modules, how they pass this, they just memorize everything. So all the course they memorize. So of course you can pass, but uh, you won't remember anything. After the module, you won't remember anything. So take it from me. I've been in this field. So in software engineering, it's all about coding. So it was about understanding the principles as well, but at the same time, it's all about you have to implement it and try it and see whether it's working. So it's better if you can do it with me. Okay. Uh, so we have created an array of 5, integer array of 5. Um, let's first print it. Okay, how do you print? File. So we'll have a for loop. I believe you are already familiar with for loop and everything, right? So let's print AI. Let's put a space in between, and then finally in the new line. Okay, is this clear? What you're gonna do is something funny, Anthony. No, it's fine to laugh. No, if you can share the joke with me, then I can also laugh with you. Okay, so is this clear, Anthony?
Yes, sir.
Okay. So don't worry, I'm not going to be that tough. Like there are some lecturers who are very tough. I am not like that. So it's okay to laugh. So so this is so what I have done here is we have created an array of 5 and we have printed it, right? So we have a for loop over here, and we are accessing each element using the index AI. So when I is equal to 0, we start with I equal to 0. So we'll be printing A0, and then we go from over here and we'll increment we increment I by 1, and then come here and see whether the condition is met, and it's actually true. So when I is equal to 1, it's lower than 5. So we come to here and we print A1. Like that, we'll be printing all the elements in this array. So let's run this and see. Because of the firewall, it takes some time on my machine. Okay, see, you can see, so we have printed all the elements in the array, right? Give me a second. Yep. So we have printed all the elements in the array. Now let's do one more thing. Let's try to print the addresses of these elements. Okay, give me one. So let's take a copy of this. And how do we print the address? 3592 Gunatilaka. How do we print the address of this itself?
Using an operator.
Sorry?
Using an operator.
Okay, good. Yeah. So just put an AND over here, and we'll see. Let's see what are the memory locations. Okay, so there is something to note here. Now, if you see, let me annotate. I mentioned that array is a consecutive, now it's a continuous allocation. Array has a continuous allocation in the memory. And because we are creating arrays of integer, so over here, let's say this is the array. So now I said that each cell is 4 byte, right? 4 byte. Now I want to take your attention over to here. Now these are the addresses that we have printed. Now if you see, take a look at these last 2 octets. 989Z, 6A0, A4, because this is in hexadecimal. Now you might not understand this 989, whether this is 4 bytes, because this is in hexadecimal. No, if I write, so in a hexadecimal, what happens is there is 1 0 to 9, and instead of 10, we have A, right? B, and 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, right? That's how hexadecimal works. So in between this 9C and 98, what we have to 9C and 98, if you can work it out later, is actually 4 bytes. There's an easy example. You see here, A4 to A0, A8 to A4. So see, all these are 4 bytes, right? Yeah, 4 bytes. So that's true, right? So as I mentioned, in array, the memory locations are consecutively assigned, right? So this is the first cell, this one over here is the first cell, and after 4 bytes, you have second cell, and then after 4 bytes, each cell is 4 bytes, right? So this is the first one. If you see, this is the first one, this is the second one, this is the third one, this is the fourth one, like that. So it's consecutively assigned, right? That's the point to know. Okay. So it's consecutively assigned. Correct. Okay. I hope you understood that. Because that's very important to understand. Okay. What else is there? Yeah. Now let's see a couple of ways you can define arrays. So I actually mentioned some of those in the slide, right? So let's see. This is one way of defining array. Let's take B. Go to the same. Let's do the same example. 5. You can all see, right? Is this font size okay? Okay. So let's take a third one. 5. Let's do 3. You remember the fourth one? Okay. So the fourth one was define the empty one, and then gonna have, yeah, like this. So as you see, these are 4 ways you can declare your arrays. Now I'm going to teach you debugging here as well. So instead of just printing these arrays, let's try to see the values using debugger. So how you put a debug point is, you just right click where you want to put, in whatever the place that you want to put the debug point. To right click, go to breakpoint, and here, because I have already inserted the debug point, shows as delete breakpoint, but if you don't have a breakpoint over there, it will show insert breakpoint, right? So now we have a breakpoint over here. Now what the program going to do is, it's going to execute all the way up to here and stop here over here. That's how you debug, right? Clear? So in order to run the debugger, earlier what I clicked was this one. So this is start without debugging. This one is the option to debug. Now you press here. You see that it will go to line 26 and stop there. Are you all doing no coding it with me? Oh, it's better if you can do that, because we won't be having any other workshops, specific workshop for this one. So what's going to happen is, I'm going to do the coding along at the same while teaching. I'm going to do the coding, right? So there won't be any separate workshops. So it's better if you can do it with me. Okay. So you see the program came to here and stopped, right? So now see this arrow point, arrow pointer. So it has stopped over here. Now it has executed up to here. You still haven't executed this one. Is it? I believe it should be like that. So and now we can, using the debugger, we can see the values. Now let's inspect all the arrays. See here you can see. Can you see over here? Okay. So you can see all the arrays that we have declared. You see A over here, right? Now I mentioned, because A only has been created or declared and haven't been initialized, what we see over here are some garbage values. We haven't assigned any of these values. See, A0 is minus 85 something, right? So again, all these are some garbage values. We haven't assigned specifically these values, right? So these are garbage values. And now if we go to B, so the B is the second array. See, so we have assigned 5 values, 1, 2, 3, 4, 5, and you can see these 5 values assigned to each cell, right? Now let's go to C. In C, we only assign 2, 3, and I mentioned remaining ones will be assigned a 0, right? See, 2 and 3 is assigned, and all remaining ones are 0. Now, if you go to the last one, okay. Now the last array, now we are at a point, we are at, at this point, this line hasn't been executed yet. So that what you see for D, is some garbage values. But if we just go over this line, let me show you how you go. So if you want to go over one line, what you have to click is this one. See, step over, right? If you click this, it will go one line, it will execute that specific line. So now we are at here. Now this line has been executed, right? Because this line is executed, now you see the values for the D is assigned 5, 6, and 8. Right? Clear? Okay. So this is how you use debugger. Debugger is especially useful to find out errors. Sometimes you do some coding, and after some point when you try to compile, you see a lot of errors, and sometimes you can't figure out what are these errors. So at that time, there are a couple of ways you can find out what's happening and where exactly is the problem. The one way is, of course, you can print. That's one simple way of doing that. You assume that the issue is somewhere over here, and then you print all these elements, and then by looking at the values, the output, you can figure out that this is the issue. Rather than doing that, what the professionals in software engineering, the coders and all, everyone does is they use debugger, right? They just put a breakpoint. They assume that somewhere over here should be the issue, and they put a debugger point, and then debug. So they have the advantage of going line by line, right? So that's the advantage of debugging, right? Yeah, I hope you are clear on that. Now these are a couple of ways you can create arrays, and let's see. You can we already demonstrated. I mean, we already went through and saw how we can access arrays. Let me show you a different perspective accessing arrays. This is only applicable or works in languages such as C or C++. It doesn't work mostly in high level languages such as Java. Let me first do it and show you. So now let's take the last array, D. In D, the size is now 3, right? Even though the size is 3, sometimes we can access beyond 3. I believe most of, because this is right after the lunch, I can understand some of you are feeling sleepy, but bear with me. I can see from facial expression, some of you are feeling sleepy. So if you want a break, just let me know. I'm more than happy to give you. Oh, I think we have already, when did we start? 12:30. Oh, they are already gone into 1.5 hours. So I was planning on giving you maybe 5 minutes or 10-minute break at the end of first hour. So, okay, I'll maybe you can take 5 minutes break, because I see that some of you are feeling sleepy. So take 5-minute breaks and be back in 5 minutes. Okay. Okay, so let me go back to the. So what I was going to show you was in actually in the previous version of C Visual Studio, uh, it was possible to access now. You see the array D is of size 3, right? It has only 3 elements, but it was possible to access even further because it's only possible. It was only possible in uh, languages such as C or C++. But now they have code it and they have no, they don't let us to run it like that. So if you see it gives a error message saying the buffer size of the size of D is 12 bytes, which is 12 bytes is three elements, right? Each byte consists of 4 bytes, so it's 3 elements. And I'm trying to access something beyond that. So, and it actually catch it as an error. But earlier, it was possible. That was actually uh, uh, maybe you can try it with some older versions of Visual Studio, or even maybe it will work in REPL. I'm not sure, but I actually tried this earlier and it was working. Probably it was with the previous Visual Studio. So again, the point is, in some low level languages such as C or C++, C++ is not so much low level, but especially this is possible in C. So you can actually access beyond what you have declared. That could be no, that could be a downfall of your program, and it may not be catched by some compilers as well. Now, in this case, they catch this error, but some compilers they don't catch this error. So because of that, what you will be doing is you will be accessing some memory of some other programs. So that's something that you need to be mindful of. Now some these modern compilers can catch this error, but earlier it wasn't possible, and especially with C, it's not, they don't catch it. So it's an advantage and also at a disadvantage. Hacking wise, that's the advantage. So you can access the memory of some other programs in as well. So what you're basically doing is you will be accessing memory that is used by another program. So that goes into the way of hacking. So because I was doing this cybersecurity and also I know. So that so that's an advantage in terms of hacking, but in terms of as a disadvantage in terms of no, running the program as you like. So if you do a mistake like this, the program won't show it. It will run, but the output will not be as you see. Okay, so there's something. Just that's it about arrays. One more thing. Let me show you the example. Now, so let me another. When you declare, so um, so when you declare an array, so what you will be writing is int a5 like this now. So you'll be writing like this. So this is a to be honest. I mean, in the ground level, this a is actually a pointer. So what this points to is the starting element of that array. This is actually pointing to the this array of 5. He is pointing to this starting element of that array. So there is another way you can access these elements using a as a pointer. That is, let me clear this. So these are some extra things. May not need it, but I'm just going to explain it. So let's try how we can do this. Let's, I don't even think. So let's try it like this. So we'll be accessing the first element. Let me see if this works. There's another way of accessing the array elements using A as a pointer. I'll take note of that. I wasn't prepared to present this, but there's a way. I'll present this later next week. So otherwise, we'll be losing some time. So okay, I'll stop it over here. Then let's go to the presentation again. Okay, we were here, right? Oh, here you see. So these are ways of you access the array. So we have already discussed these, some of these. Please take note if you want to, because there won't be a separate note. So this is all it, right? So we have discussed this, right? This one is done. Yeah, this is what I was talking about. So as I mentioned, A is acting as a pointer as well. So A is basically pointing to the starting element of that array, right? So if you type star A and if you assign some value to it, what it happens is we will be replacing the first element 12 over here. So these two are pretty much same. Okay. So if you do it like this, what you will be accessing is this second element. Okay, this one. This is second element. So of course the conventional ways of accessing elements is using the index like this. And the last one was this, what I was talking about. So usually C++ doesn't check the boundaries of the array. So be mindful when you're accessing. So it seems that the modern compilers check this one, but earlier it wasn't. So it usually don't check. So you can actually access beyond what you have declared. This could be dangerous in programs as well. So these are ways of accessing arrays. And what's the time now? We have 15 minutes, right? So next thing is heap and stack memory. Okay. I hope that you are clear on the array. Array is actually very important. We'll be using arrays for many of the data structures that will be coming up, such as stacks and queue. So it's important that you understand the arrays to a certain level. So what we have now is heap and stack memory. So this stack is this. So there's a data structure called stack. Here we are not talking about that. Okay. So this here what we are talking about are memory structures. So heap memory is inherently slow, and stack memory is very fast to access and very fast to create. So why? If it is the case, why do we need heap memory? So let's see why do we need heap memory? For that, first we need to understand how stack works. Okay, so let me explain this with the example. Let's write a program here. Okay. So over here, where's the mouse? So let's write a program. Let's say I'm going to write the main part only, int main. Okay. And parentheses, we have a variable called int x, int, let's say int y, and let's say we have a function called function a. Okay, so we have two variables and a function. Okay, so let's see how this is resembled in the memory. So in memory, there are three main parts. So in the memory, there are three main parts. The first one is code. Your whatever the code you will be writing goes to the bottom, and on top of that, the variables that you declare will be created in the memory as heap or stack. This is how your memory works, right? So you basically have the fundamental code over here, and on top of that, you have heap and stack. Now, in this example, so basically, any array that you declare will be stored in the stack memory. That's why arrays are very fast. So in this example, how the memory works is, let's say you have a memory like this, and you have the code goes to the bottom. So this is your code, and on top of that, so let me choose another color. Black. So so there will be a so for each scope a stack of memory will be created. Now for the main, there will be a stack of memory created. So this is the main function. So for that, a stack of memory will be created, where inside that we have x. So there's this x and this is y, right? So, and we have the function, right? For the function, again, another stack of memory will be created. For each scope, a separate memory stack will be created. So this is the memory stack is created for the function a. Okay. So inside, let's type the definition of function a. Okay. Let's type the definition of function a. Let's say your function is void function a is let's say there's a variable called int a inside this function. So here also there will be a variable called a created in this stack. Now the problem with stack is we cannot delete any memory depending on our preferences. The memory that is created on stack will be deleted based on the operation of the program. For example, how your program first works is it goes to the main, right? Inside main, it will create x, it will create y, and then it will go to the function a, and it will create another separate stack for function a. Now, once function a is executed, after the function a is executed over from here, it will return to over here, right? No, so now when it returns to here, the main stack, this function a will be automatically, this memory stack will be deleted. So it will be deleted by the system, the operating system itself, not by us, right? So, so once it is executed and if it's done, then it will be deleted. Now it won't be deleted right after, but now depending on how your memory is available, I have now tried it out with a couple of examples and so that it won't be deleted right after, but after a certain time it will be deleted. All right. So that's how your stack memory works. So the thing is, now when we are here, when we are in this let's say when we are inside this function a, now let's say we are here, we can't delete any memory that is in main. We can't delete x or we can't delete y, right? So it will be deleted by the system. Now, once it is executed, it will be deleted, right? So that's how it works in stack. Now, going to yeah, I should have drawn all that here. So, okay, so I think we went through the stack. Now, going to the heap memory. Heap memory is created with the variable new. So you see here, new, this variable. So it is created using this new variable, and we have the opportunity or the access or the freedom to delete any of these variables that is created using new by ourselves. So how we do it, maybe if we take this example, what happens here is, you see, so we have created a passenger class, right? And yeah, there's a passenger class. Inside the passenger class, there are a couple of attributes such as name, meal preferences, frequent flyer number, and etc. So uh, so we have created this variable using the the command or the at what is the proper word? Let's say, okay, we have created this using new, right? So in such a case, we can delete this p variable using delete p. See, if you write delete p, it will create any memory that is allocated for p, right? So p is actually a pointer, right? You should see here it's a star, so it's a pointer. So with this delete p, we can delete this pointer and any memory that is assigned to p as well. So if it is just a single variable, this is how we delete, just delete p. Now if it is a array, see this is here, it is in this example is an array, right? It's an array of chart, right? So in that case, if you want to delete that, the command to delete the array of that is created using the new command is delete the parenthesis and the variable name. So all this will be actually created in the heap memory, which is much slower than the stack memory. But there's a use case, right? So the difference is we can't delete the memory, the variables that is created in the stack memory. However, we can create delete the memory that is allocated in the heap memory. So that's the main difference, right? So you need to not take note of that. Right. So that's the difference between heap and stack. Let's see whether we have. Yeah, so if an object is allocated with new, it should eventually be deallocated or deleted with the command delete. Okay. So with that, we have 5 more minutes, right? Okay, we can finish this off. So what? Oh, okay, so this is about how do you, in the beginning I mentioned that with arrays the size is fixed, you can't change the size. Now if you want to change the size, there's a certain procedures associated with it. So if you want to change the size of an array, first you need to copy the current array into a temporary variable, and then you have to create a bigger array and then copy this temporary variable, the array that was copied to the temporary variable, the array into the original array. This is what is happening here. So let's say we want to yeah, so let's say we want to so we have an array of 5. So let's say here we have an array of 5. We want to create an array of 10. Okay, so we want to increase this size of this array. So in that case, what we can do is, let's first we need to create an array of size 10, and then we need to copy whatever that was there in array A into this new array, right? And then we need to delete.
delete A, which was the original array, this one, right? And then now what we have is we have the temp, right? The temp is the array that was that with 10 elements, right? That's the bigger array. And then we have to assign temp to this original A. So that's how you create or increase the size of array. Just if you have any questions, please you can ask. So maybe if I explain it again. So what happens here is you have A, this array of 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then what we will be creating array of called temp, which is it has so 10 elements. Let's say 1, 2, 3, 4. Let's say 10 elements. Okay, and so the first 5 will be copying. The first 5 with this for loop, what we are doing is we are copying the first 5 from A to this temp, right? We are copying the first 5 into A to temp, and yeah. So after that, we are going to delete this reference, this pointer. So we are going to delete this one. Okay. So whatever the memory allocated for this will be gone, right? With this delete, with this command, whatever the memory allocated for this will be gone, and then we assign temp to A. So finally, what we have is an array of A which has 10 elements, right? So that's the way to if you want to increase the size of the array, that's the way to do it. Okay. With that, I believe what is left is for us to talk about 2D arrays, because there is only 2 minutes left. I'm going to stop it for today. We can discuss 2D arrays. We have lectures on Friday, right? So we can discuss it Friday. So meanwhile, if you have any questions, please feel free to ask, or you can put questions on the forum in the LMS, or you can mail me. Everything is fine. By today, I'll go back and I'll see whether I have missed anything, because I'm also doing this course for the first time. So I'll see whether I have missed anything. And if I missed anything, I'll teach them, I'll pick them up by Friday during the next lecture. And we can have a discussion on that. So the last 1 or 2 minutes you have, can raise if you have any questions. Do you have any? Or how is this pace is okay for you? Like today's lecture, was it okay for you? Any comments on the lecture or anything? Well, we have 1 more minute. If you have any questions, you can drop it in the chat. So I'll here for 1 moment. I'll be doing some. I'll do some like more examples using Visual Studio on this Friday. I was planning on doing a couple of more, but the time wasn't enough. For example, this array accessing, maybe I can do a couple of more examples, and heap and stack memory also. Maybe we can do a couple of more examples. Yeah, then we can finish up the 2D arrays, and then by next week we can go to linked lists, I believe. So any questions? I'll be happy to answer any. I mean, this has to be a two-way dialogue. It's not just me delivering the content. There should be some feedback from you, right? Anthony, do you have any questions? Somehow
No, sir.
your name, your picture comes up in the first page, like in the first screen. So that's why I never put my like මගේ ළමයාගේ නම මම ඒ අකුරෙන් පටන් දැම්මේ නැහැ. මුලින්ම එන්න වෙනවා හැමතැනම. And you are smiling all the time, so there'll be a lot of questions coming on at your way in next couple of weeks. Okay. By the way, do you play basketball? I believe I saw you in the examination hall. You are very tall and all, right?
Yes, sir.
Do you want to play basketball? Oh, are you
Yeah,
playing?
I'm playing.
Oh, okay, good. There was so the two of us players got selected for the national team, right? Was it you? Like one was you, is it?
Yes, sir.
Also you. Oh, okay. Good. So you and who was the other one? The captain, right?
Yeah.
Okay. Okay, good. Okay, so you don't have any questions, so we can wind up. Okay, see you on Friday. Thank you.